G'day folks, I'm going to work through as the last exercise in the work we're doing on linear functions, on basically equations of a straight line. I'm going to work through the last exercise in the Cambridge Year 11 Advanced Mathematics textbook. This is exercise 6E, question 9. So we're told that we've got these 3 points. A is the point is the point 1, negative 2, B is the point 5, 6, and C is the point negative 3, 2. I've drawn them, and then we're told that P, Q and R are the midpoints as shown on the diagram. So P is the midpoint of CB, Q is the midpoint of AC, and R is the midpoint of AB. As you can see there on the diagram. Part A, section 1 of the question asks us to find the equations of the medians of the triangle BQ. So a median, any triangle I have, so any triangle, a median is that line which goes from a vertex to the midpoint of the opposite side. So that line there is a median. The median of a triangle, okay? So we've been asked to find the equations of the medians in this triangle here. So I didn't want to clutter up the diagram and have scribble going all over it. So I've just drawn it there. And if you want, you can sort of take it away and actually sort of, sketch up a number of copies of this, and you can show the different medians if you like. We don't really need to see the median to find its equation. In fact, we don't need to see the median at all to find its equation. All we need to find the equation of a line, as we've seen in past videos, is 2 points, or a point and a gradient. Okay, so let's have a look at what we've got here. So if I want the equation of BQ, well, I've got the coordinates of B. I need the coordinates of Q. Okay, I'm told that Q is the midpoint of AC. So I need to use my midpoint formula to find the coordinates of Q there. So let's do that. Okay. So coordinates of Q. Let's find them. So it's the midpoint of AC. So I'm just going to use the midpoint formula to get me out of trouble here. Midpoint formula says x1 plus x2 on 2, y1 plus y2 on 2. Okay, so this is we're finding the point Q. So Q is equal to, it's the average of these x values and the average of these y values here. So the average of negative 3 and 1, and the average of 2 and, sorry, I got that around the wrong way. So the average of 2 and negative 2 there. Okay, so average of the x values, average of the y values. So let's do that. So the average of my x values is negative 3 plus 1 on 2, and the average of my y values is 2 plus negative 2 on 2. Okay, well that's negative 2 divided by 2. That's pretty simple, it's just negative 1. And that's 0 divided by 2, that's 0. So the coordinates of Q is negative 1, 0. We can actually add that to our diagram if we want. Negative 1, 0. Okay, well now that we have that, we can work out the equation of BQ, because we've got the coordinates of B and now we have the coordinates of Q. So I'm going to get rid of this working here, so I've got some room to work out the equation of the line BQ. So the equation of BQ is going to be found using the 2-point formula. So we're going to use y2 minus y1 over x2 minus x1. Sorry, let me try that again. Y minus y1 over x2 minus x1 is, goodness me, I'm having a bad morning, folks. Y minus y1, take 3, right? Everyone makes mistakes, just as long as you're on top of them and you can fix them up, it's not so much of a problem. Y minus y1 over x minus x1 is y2 minus y1 over x2 minus x1. Okay, so let's go through carefully using these coordinates 5, 6 and -1, 0, carefully substituting them into the formula for the equation of a straight line. So I've got y minus 0 over x minus -1. So I'm using q as my x1, y1. It doesn't really matter, it's completely interchangeable. I'm just using this one because I like the fact that there's a 0 there, it'll get me out of trouble pretty quickly. Equals y2 minus y1 over x2 minus x1. Okay, so over here I've got y minus 0 is y over x plus 1 is 6 over 6. So I've got, that's 1. So I've got y over x plus 1 equals 1. If I multiply that x plus 1 over here, I've got y equals 1 times x plus 1 is just x plus 1. So I've got the equation of the line BQ, it's y equals x plus 1. Okay, so we're going to go through exactly the same process to find the equations of CR and AP. So we need to find the midpoint of AB, which is going to use the midpoint formula again. That'll give me the coordinates of R. We're going to find the midpoint of CB. That'll give me the coordinates of P. Then we're going to use the 2-point formula like we just did between C and R and between A and P. Okay. So let me just cheat a little bit and I'll just sort of jump ahead. The midpoint of AB is going to be 3, 2. And the midpoint of CB is going to be 1, 4. Okay, so I mean, in an exam situation, you wouldn't want to just sort of write down, unless it was only worth 1 mark and you could see it just like I did. You wouldn't want to just write it down, you'd want to go through the motions like I did before I rubbed this work out, going through and actually showing the examiner where you're getting your numbers from. Okay, so I've got the coordinates. Now I want to find the equation of CR. Okay, well if you have a look, let's pay a little bit of close attention to the coordinates. Actually look at the numbers. C has got a y value of 2 and R has got a y value of 2. So CR is a horizontal line. We know the equations of horizontal lines. Okay, the equation of a horizontal line is y equals whatever our y value is. So the equation of CR, the equation of CR is y equals 2. Now, let's say you didn't see what I just saw. Let's say you didn't pick that they've got the same y coordinates. Were you to put these numbers into the 2-point formula, the 2-point formula would take care of the details for you. Okay, so look, let me show you that. So let's say I couldn't just see that. Let me neaten that up a little bit. Let's say I couldn't just see there was y equals 2. If I was to use the 2-point formula, this is what I'd see. I'd see y minus y1 over x minus x1 is y2 minus y1 over x2 minus x1. So I'd get, let me pick on this as x1, y1 and x2, y2 over here. So I'd end up with y minus 2 over x minus minus 3 is 2 minus 2 over 3 minus minus 3. So I get y minus 2 over x plus 3 equals, now look at this right hand side, I've got 2 minus 2, this is going to be 0, the whole fraction is going to be 0. Now look what I've got here, I've got a fraction that equals 0. The only way a fraction can equal 0 is if the numerator is 0. So y minus 2 is 0. In other words, y equals 2. So we would have got to that same point, whether we went through the motions of using the 2-point formula, substituting values in, we still would have got to y equals 2, or we could have just used, looked at the numbers and used our nous about what do we know about horizontal lines. Okay. So now we just need to find the equation of the line AP. I'm running out of board space. So what I'm going to do is I'm going to write down the equations of BQ and CR, and then I'm going to work out the equation of AP. So the equation of BQ we got was y equals x plus 1. The equation of CR was y equals 2. Now let's work out the equation of AP together. So for the equation of AP, again, look what's going on here. Again, let's look at the numbers. We've got an x value of 1 there and an x value of 1 here. It's going to be a vertical line. Okay, vertical lines, we know them, we know their equations. Again, I'm not going to go through all the motions here, but we know that the equation of AP is x equals 1. Okay, by exactly the same argument. Okay, so let's press on, let's keep on going. I need to just wake up the computer because I've lost the rest of the question here, so just give me a moment. Righto, I just economised up a little bit on my blackboard then, and I woke up the computer from its nap. So part 2, so question 9a part 2 asks us to find the intersection of BQ and CR. So BQ, so the intersection of this median here, BQ, and the intersection of that median there. Okay, and then it asks us to show that it lies on AP. So for something to lie on AP, it must have an x-coordinate of 1. So I need to show that the intersection of BQ and CR, well, first of all, I need to find that intersection, and then I need to show that it has an x-coordinate of 1. So let's do that. Okay, so solving BQ and CR, I'm just going to solve those equations simultaneously. So if you have a look, BQ and CR are both expressed in terms of y. So BQ is y equals x plus 1. CR is y equals 2. It's begging me to do a substitution. Okay, so I'm going to do that. I'll use the substitution method. So we can substitute B or CR rather. Substitute CR into BQ. In other words, everywhere I see a y in BQ, I'm going to put in 2. So let's do that. So I get 2 equals x plus 1. Well, the only way that can happen is if x is equal to 1. So straight up, I know that now that the intersection of BQ and CR lies on the line AP. But they didn't ask me just to find that it lies on the line, they asked me to find the whole point. So I need to find the y value as well. Now look at this. CR tells me what the y value is. Okay. So from CR, y equals 1. Therefore, the intersection is the point 1, 1. Hi, I obviously made a silly mistake then. The point is 1, 2, not 1, 1. The things you find in post-production. Sorry guys. Anyway, it doesn't affect the rest of our solution. Just to let you know that that point was actually meant to be 1, 2, not 1, 1. Sorry about that. Okay, and this lies on AP because it's got an x-coordinate of 1. Okay, so that's all of question 9, part A done. Part B now is the real meat and potatoes of the question. Okay, so let's start to get into part B. I'm going to clean the board and then come back for part B, because part B takes the ideas that we saw in part A and applies them in a way where we're not looking at the numbers anymore. Now we're looking at pronumerals. So I'll clean the board. I'll be right back through the magic of time, television, YouTube, whatever it is. Okay, back in a sec. Righto folks, welcome back. Part B tells us to consider the 3 points A, B and C. Again, we're talking about a triangle. A's got coordinates 6A, 6B. B has got coordinates negative 6A, negative 6B. That's right. And C has got coordinates 0 and 6C. So don't be tempted to think, oh, they're all 6s, so C is going to be up here, horizontal from A. It's not. So this is 6 times C, this is 6 times B, so they're at different heights, okay? And we don't know the size of A or B. That doesn't really matter. We're just going to let the algebra do the talking for us. So part A says, find the midpoint P, Q and R of BC. So P is the middle of BC, Q is the middle of CA, and R is the middle of AB. Well, look, we can cheat a little bit here. The middle of AB should be very, very obvious to us. Look at this. B is at negative 6A, C is at 6A. Well, what's in the middle of negative 6A and 6A? 0. B is down here at negative 6B, and A is up here at 6B. What's between 6B and negative 6B? Again, it's 0. So we know that the point R is here at 0, 0. Okay. So we can, use our now, so it's not going to be that difficult. Between negative 6A and 0, between negative 6A and 0, what's halfway between 0 and negative 6? Well, negative 3. So halfway between 0 and negative 6A, and negative 6A, it'll be negative 3A. So over here we are at, so P is at negative 3A. And then what's halfway between 6C and negative 6B? Well, that's going to take a little bit of thinking. We can use the midpoint formula if you like. So if we wanted to find P, we'd use the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. So P is going to equal, we've seen what the middle of the x values are, but let's do it anyway. So negative 6A plus 0 over 2 and negative 6B plus 6C over 2. Okay, so just x1, x2, y1, y2, just getting the averages of both. So here we're going to get negative 6A plus 0 is negative 6A divided by 2 is negative 3A. Over here I can divide everything by 2, so I get negative 3B plus 3C. That's a bit of a nasty way to write it. I don't like that negative sign out the front, so I'm just going to change the way this is written to 3C minus 3B. Okay, negative 3B plus 3C is exactly the same as 3C take away 3B. Okay, so multiplication is commutative so long as you subtraction rather is commutative rather. Goodness me, something's happened to my my nouns, verbs, and adjectives today. Addition and subtraction are commutative so long as signs follow the numbers. So I can swap these around so long as that negative sign goes with the, it moves with the 3b. Okay. Rightio, so I've got the coordinates of P, 3c minus 3b. Okay, now I need the coordinates of Q. Well, I'm going to go through a very, very similar calculation there that I did here. I'm just going to get the middle of 0 and 6a. So that's going to be at 3a. And then I'm going to get the middle of 6c and 6b. Well, the middle of 6b and 6c, think about that. 6b, okay, my camera just stopped recording and I don't know exactly what point, so I'm going to rehash a little bit of that. Let me back up to here. So when we wanted to find the midpoint, we wanted to find P, the midpoint of B and C, I just applied the midpoint formula. So negative 6a plus 0, negative 6a plus 0, adding the x values and then dividing by 2 to get the average. And then negative 6b plus 6c, adding the y values and dividing by 2 to get the average. I then simplified, so negative 6a divided by 2 is negative 3a. Over here I divided everything by 2 just to simplify, so negative 6 divided by 2 is negative 3, 6 divided by 2 is 3. Then I just swap these guys around, okay? Just so it was a little bit neater so I didn't have that nasty negative sign hanging out the front. Then I needed to find the coordinates of Q. Okay, so to find the coordinates of Q, I've got the average of the x values here, 0 and 6a. That's pretty simple, it's going to be 3a. And the average of 6b and 6c. Well, here's the algebra for that. 6b plus 6c divided by 2 is 3b plus 3c. So this guy over here is 3b plus 3c. Okay. So they're the coordinates of my midpoints, which is the first little bit of work that the question B, part 1, asks me to find. Okay. Then it says show the median through C. So what's the median through C? Well, the median, remember, goes from C to the middle of the other side. Okay, so in other words, CR. They say show the median through C is x equals 0 and find the equation of the other two medians. Okay, well, let's do that. Let me get rid of this. Okay, so the equation of CR, well, I can argue very, very simply, this is a vertical line through 0, 6c and 0, 0. Therefore, the equation is x equals 0. Okay. Then it says find the equation of the other two medians. Okay, so in other words, now I need to find the equation of AP, and then I need to find the equation of BQ. So I'll do them in that order. So for the equation of AP, I'm going to use y minus y1 over x minus x1 is y2 minus y1 over x2 minus x1. Okay, so using A and P, so let's go. Y minus 6b over x minus 6a is y2, 3c minus 3b, minus y1, 6b, over x2, negative 3a, minus x1, 6a. Okay, so let's neaten that up a little bit. I've got y minus 6b over x minus 6a equals 3c minus 9b over negative 9a. Now you're probably looking at that and thinking, gosh, Mr. Obeid, there's lots of really nice threes that'll, there's a 3 that'll cancel out from everything in there. So let's do that. Let's divide everything in this fraction by 3. I'm just going to clean the top up my board so I can keep on working up there. So I've got y minus 6b over x minus 6a is c minus 3b over negative 3a. So now I'm just going to multiply my x minus 6a, my denominator from here across. And while I'm at it, I'm probably going to multiply my negative 3a, my denominator from the right hand side across to the left hand side. So I've got negative 3a outside of y minus 6b equals x minus 6a outside of c minus 3b. Okay, that leaves me with a binomial expansion. I'm just going to do that now. So over here I've got negative 3ay plus 18ab equals, and here's my binomial expansion, x times c is cx, x times negative 3b is negative 3bx, negative 6a times c is negative 6ac, and negative 6a times negative 3b is plus 18ab. Now look at that really carefully. What you'll see is that both sides of my equation have got a plus 18ab. Okay, I've got that on both sides of my equation. So I can just cancel that out of both sides of my equation. Okay. What I'm going to do now, I might sort of arrange this into a general form. I'll arrange it into a general form. So I've got, or something approaching that. I've got c minus 3bx. So look at this. There's an x here and an x in here. I'm going to pull that out to this side. So this would be cx minus 3bx, which is that there, minus, sorry, let me slow down a bit. I'm going to take this negative 3y from the left-hand side, I'm going to add it to the right-hand side, so plus 3ay. And then I've got a negative 6ac, that equals 0. So that's the equation of AP in a general form, if you like, okay? So there's AP. Now we're going to go through some of the same, well not some of, exactly the same process to find the equation of BQ. Okay, so let me save a bit of room over here. I'm just going to write down what we know so far. So CR is x equals 0. AP is c minus 3bx plus 3ay minus 6ac equals 0. And so now we just need to find the equation of BQ. Okay, so BQ, let's go. We'll just use our 2-point formula again. Y minus, so we should say what we're talking about here. So for the equation of BQ, we've got y minus y1 over x minus x1 is y2 minus y1 over x2 minus x1. Well, y minus y1 is y minus 3b plus 3c over x minus x1, x minus 3a. Now make sure I put it in brackets, you make sure you put it in brackets as well, because the minus doesn't just mean minus 3b, it means minus 3b plus c. So make sure you put that 3b plus c in brackets, so the whole thing is being subtracted. On the right hand side I've got y2, negative 6b, minus y1, again the brackets, 3b plus 3c, over x2, negative 6a, minus 3a. So let's go through the same algebraic process we did last time. Here I've got y minus 3b minus 3c, multiplying the negative 1 by both terms, over x minus 3a. Over here, look at this, I've got negative 6b minus 3b. Well, that's going to be minus 9b. Then I've got minus 3c. Well, that's that there. Then on the bottom, I've got negative 6a minus 3a is minus 9a. Again, look at that, it's begging to have 3 cancelled out of everything. So I'm going to divide everything on the right-hand side by 3 to simplify that fraction. In fact, I want to divide everything on that side by minus 3 to simplify that fraction. So I'm going to get a 3b plus c over 3a. Yeah, neaten that up a little bit. So I divide everything by negative 3. Over here I've still got my y minus 3b minus 3c over x minus 3a. Again, I'm going to multiply the denominator over here across, and I'm going to multiply the denominator over here across, and then simplify. There's no way in the world I'm going to fit that down here, so I'm going to rub out up here and keep on working down. So I get 3a outside of y minus 3b minus 3c equals x minus 3a outside of 3b plus c, and it's expanding brackets now on both sides. So 3ay minus 9ab minus 9ac equals, well look, x is going to multiply that whole bracket, so I'm just going to write that as x times that whole bracket, 3b plus c. Otherwise I'll be expanding and then factorising again like I did last time. I don't need to go through the pain. So x times that bracket, and then negative 3a times that bracket. This one I'm going to expand. So negative 3a times 3b is minus 9ab, and then minus 3a times c is minus 3ac. Now look at this, there's a negative 9ab over here, and there's a negative 9ab over here. They're the same thing on both sides of the equal sign, can just be eliminated. Now I'm just going to move everything over to the right hand side. So I'm going to be left with a 0 over here. I've got x times 3b plus c. Then I'm going to have a minus 3ay when I move this over. Then look at this, I've got minus 3ac plus 9ac. Well, minus 3 plus 9 is plus 6. Okay. So in other words, the equation of BQ, I can now write up here in my collection of equations as 3bcx, sorry, 3b plus cx, my apologies, minus 3ay plus 6ac equals 0. Okay, so I've got the equations of my three medians. Now there's a heck of a lot more algebraic work in these coordinate geometry problems where we are using pronumerals, but I mean, you know, they don't call it advanced maths for nothing, guys. Doesn't that remind you of the Braveheart line? We didn't get dressed up for nothing. We didn't get to advanced maths for nothing. Okay, so what we're trying to do is to now show, so I'm reading part 3 now, I'll read it verbatim. Find the point where the median through C meets the median through A. Well, here's the median through C, and here's the median through A. So it says find the point where the median through C meets the median through A, and show that this point lies on the median through B. So what we need to do is to find that point there, and then show that that point lies on this line here. Okay, in other words, we're going to show that they're concurrent lines. Now, a little bit of geometry aside, if you actually have a triangle, it doesn't happen with every triangle, but if you've got a triangle where you've got your medians, actually maybe it does happen with every triangle. I might have spoken too soon. But where the medians of a triangle cross, if the three, where those three medians cross, that point of concurrency is actually called the centroid. I think I might have spoken too soon. I think every triangle's got a centroid. I need to do some thinking about that one. I think I'm pretty sure it does anyway. It's been a long time since I've done that sort of geometry, so I've forgotten it. But that's called the centroid. So a little bit of geometry work just sort of slipped in there. But where the medians cross over, that point where all three cross is called the centroid of the triangle. G'day guys, I checked and yes, every triangle has a centroid. Unfortunately, geometry's been sort of had the guts kicked out of it in the HSC course, so we won't get a chance to go over that in class. But if you're interested, let me know and I'll show you one day. Anyway, that's a little bit of geometrical trivia. We're only interested in the algebra of our current problem here, right? So we need to find this point. Well, we know the x value, right? The x value has to be 0 because it's on the line CR, and CR is x equals 0. So we just need to find the y value of AP. In other words, we're after the y-intercept. How do we find y-intercepts? Well, we find y-intercepts by letting x equal 0. So let's do that. So in AP, we desire to find the y-intercept. Okay, so we're going to let x equal 0 in AP. Okay, so if I've got c minus 3b, that is c minus 3b times 0 plus 3ay minus 6ac equals 0. So I let x equal 0, okay? Well, that means this whole thing is going to be 0. This whole thing here is just nothing. I'm going to take the minus 6ac to the other side. Then I'm going to divide by 3a. Well, that's pretty simple. The a's cancel. 6 divided by 3 is 2, so it's just 2c. So the point here, this point here is 0, 2c. Now I just need to show that 0, 2c lies on the line BQ. How do I show that a point lies on a line? Well, that's right back to the very first thing we saw in this coordinate geometry work after distance midpoint gradient. The first thing we saw when we looked at equations of lines. I know that a point lies on a line if that point satisfies the equation of the line. So let's stick our values in and see if we get a true statement. Let's have a go. Now, we're asked to, we have to show that 0, 2C lies on BQ. So that's our aim. Our aim is to show that 0, 2C lies on BQ. Well, the way we're going to do that is we're going to use our proof. We're going to check to see if 0, 2C satisfies BQ. Okay, let's do that. I'm going to let x equal 0 and y equal 2C. 3b plus c times 0 minus 3a. Instead of y, I'm going to write 2c plus 6ac equals 0. Well, all this times 0 is nothing. And over here I've got minus 3a times 2c. Well, that's minus 6ac plus 6ac equals 0. Minus 6ac plus 6ac is 0. So I get 0 equals 0. That's a true statement. Therefore, 0, 2c lies on BQ, as required to be proven. That's a heck of a lot of work, guys. Okay, I'll get out of the way of the algebra there so you can just sort of see it one more time. There was a heck of a lot there, but look at the actual coordinate geometry, look at the actual equation of a line concepts that we saw here. What did we need? Well, we needed midpoint, we needed equation of a line, we needed the 2-point formula, we needed to know how to solve, find the intersection of two lines, or in other words, solve simultaneous equations. We needed to know about equations of vertical and horizontal lines. What other things do we need to know working through question 9? We need to know how to determine whether a point lies on a given line. All of it is applications of very, very, very straightforward Year 10 ideas. But with these pronumeral substitutions, the algebra gets much more complicated. You've got to be a lot more careful with your algebra. Okay, so don't let exercise 6E scare you. You just need to be careful with your algebra. Okay, pay attention to detail. If something has gone wrong, look at your algebra. If you can't see the mistake, snap a photo and send it in to me, or ask me to just do the question for you, and I'll be happy to do that. But don't panic. It's not that, oh, I'm dumb, I don't get it. You're not dumb at all. Everybody makes simple algebra mistakes. Everybody. Right? So you just need to calm down and to stop and go through your algebra very carefully. See if you can see where your mistake is. I hope you don't make any. Good luck. If there's any questions, any problems, anything at all, let me know. Comments below. Get me on Microsoft Teams or send me an email. Take care, guys. Thanks.